Last week we talked about how clouds can help to understand and forecast the weather. So this week we're going to do a little forecasting kind of 101. I think we're all pretty familiar with Ben Franklin and his kite flying experiment, but another guy who really got weather forecasting going is Lewis Fry Richardson. In the early 20th century, he suggested a structure for weather forecasting using mathematics and differential equations. This is still the method we use now, but with much more powerful and faster computers. In the 1930s, aircraft stations were used to make upper atmosphere observations. Upper atmosphere observations have a strong impact on ground level weather patterns, so this became a major advancement. Another major advancement actually began as a byproduct of World War II technology to track enemy aircraft during the Battle of Britain in 1940. Radar stands for radio detection and ranging, and works by transmitting pulses of radio waves from an antenna. When it meets a target, some of the beam is reflected back. That's how it was realized that it could also detect rain. The radio waves bounce off water droplets and ice crystals to warn us of imminent formation of thunderstorms, tornadoes, and hurricanes. Doppler radar is an advanced kind of radar that not only finds areas of precipitation and the intensity, but also measures wind speeds. Also in 1940, the use of radiosondes and weather balloons expanded rapidly. This is a small expendable instrument package carried by a hydrogen or helium-filled balloon. They rise about 300 meters per minute and give us information about pressure, temperature, and humidity in the atmosphere. The results are transmitted to ground stations by radio, hence their name. All observations are usually taken at the same time each day, once in the morning, evening, and 365 days a year. When severe weather is expected, additional soundings may be taken to gather storm developments. Like on radiosondes, instruments that you find on a weather station are thermometer, anemometer, barometer, hydrometer, and rain gauge. Thermometer measures air temperature, typically contains mercury, which expands or contracts. Anemometer measures wind speed and has those revolving small cups. Barometer measures air pressure. Gases in the Earth's atmosphere have a weight, and these exert a pressure on the Earth's surface. That weight is measured by the barometer. If air pressure is rising, that indicates a trend towards more settled weather. A drop in the barometer indicates unsettled conditions, likely the approach of a low-pressure system. Hydrometer measures moisture content, or humidity of the air, and rain gauge measures rainfall. The temperature, wind, dew point maps that you see on TV, those measurements mainly come from sensors or automatic weather stations. This makes it possible to get weather information timely and from a local to large scale to show current conditions, weather patterns, or when the next storm system will be here. A vital weather instrument tracking those storm systems are satellites. Satellites orbit the Earth, taking pictures and collecting measurements of the upper atmosphere. Computer programs then use these consecutive satellite images to analyze how cloud patterns move with the winds. TIROS was the first weather satellite, launched on April 1st, 1960. And now 60 years later, they have become essential for monitoring severe weather, especially hurricanes. Two common types of satellite images are taken in visible and infrared wavelength. In visible images, white areas indicate where clouds are present. Infrared images show cloud temperature. All that we have talked about has drastically improved over the years, and forecasts will continue to improve as we get faster computers, more data, and find better ways to measure the atmosphere. For your 7-day forecast, rain and storms return tomorrow and over the weekend. Temperatures are staying in the 60s to 70s. Stay safe, healthy, and see you for next Weather Wednesday.